Alright, let's dive into something mind-blowing that just happened in the world of physics and AI. Imagine this: a Nobel Prize-winning physicist and his colleague, stuck on a decade-old mathematical problem, finally crack it, not with years of additional human insight, but with the help of an AI model. Sounds like the plot of a sci-fi movie, right? But it's real, and it's raising some massive questions about the future of research. Personally, I think this story is a perfect example of how AI isn't just a tool, it's becoming a collaborator, pushing the boundaries of what we can achieve. But let's break it down, because there's so much more here than just a problem being solved. First, let's talk about the problem itself, jamming. No, not the kind you experience in traffic, though it's surprisingly related. Imagine a box filled with spheres floating in zero gravity. As you add more spheres, they start to crowd each other until, at a certain point, the entire system locks up. It's like a sudden transition from a fluid to a rigid state, but without any order. What makes this really interesting is that jamming isn't just about physical spheres, it's a mathematical problem called constraint satisfaction. Think of it as a puzzle where you have to satisfy a bunch of rules simultaneously. The more rules you add, the harder it gets. Sound familiar? It's basically what happens in machine learning models, or even our brains, when they are overloaded with data. From my perspective, this connection between physics and AI is one of the most fascinating aspects of the story. It's like these two fields are speaking the same language, and AI is helping us translate. Now, here's where it gets wild. The physicists, Francesco Zamponi and Giorgio Parisi, noticed something bizarre in their calculations. Two parameters, A and B, always added up to 1. But they couldn't prove why. Enter Claude, the AI model. What many people don't realize is that AI isn't just good at crunching numbers, it can also spot patterns and intuitions that humans might miss. In this case, Claude didn't just give them the answer, it showed them a simpler way to think about the problem. Personally, I think this is a game changer. It's not just about solving one problem, it's about AI helping us rethink how we approach problems altogether. If you take a step back and think about it, this could revolutionize how we do research across disciplines. But let's pause for a second. What this really suggests is that AI isn't just a tool for solving problems, it's a partner in discovery. Zamponi even calls it a telescope for the mind, which I find absolutely brilliant. It's like AI is extending our cognitive abilities, allowing us to see things we couldn't before. However, this raises a deeper question. If AI can come up with insights that humans miss, how do we ensure we understand why it works? This is the black box problem, and it's a big one. In my opinion, transparency is key. That's why Zamponi and Parisi published their full conversation with Claude. They want to show how the AI arrived at its solution. This isn't just about credit, it's about making sure we can learn from the AI's thought process. Now, let's talk about the bigger picture. Zamponi believes AI could be more important than the Industrial Revolution or the Internet. That's a bold claim, but I think he's onto something. Imagine a world where scientists can test ideas at lightning speed, where interdisciplinary research becomes the norm because AI can bridge the gaps between fields. But here's the catch: with great power comes great responsibility. We are already seeing a flood of low-quality, AI-generated research, and it's straining the peer review system. One thing that immediately stands out is the need for new frameworks to integrate AI into education and research responsibly. We can't just hand students and researchers these tools without teaching them how to use them ethically and effectively. Finally, let's circle back to jamming. Zamponi is now applying this approach to another problem called random sequential absorption, RSA. It's a different process, but it's related to jamming in how it describes systems locking up. What's fascinating here is how AI is helping us connect these dots, showing that seemingly unrelated phenomena might follow the same underlying principles. This raises a deeper question: How many other connections are out there, waiting to be discovered with AI's help? Personally, I think we are just scratching the surface. The future of research isn't just about humans or AI, it's about the partnership between the two. So, here's my closing thought. AI isn't just solving problems, it's changing how we think about problem solving itself. But with this power comes a responsibility to use it wisely, transparently, and ethically. What do you think? Are we ready for this new era of discovery, or are we still figuring out how to navigate it? Let me know in the comments. I'd love to hear your thoughts.